Shh. Let's start class. Hey, Ghislaine, how are you?
Okay.
Good.
How about you?
Good, thanks. Hey, I found out today that we're getting that funding for the Cal State San Bernardino grant. So you should be able to also touch base with Skip about getting at least a certification voucher in the upcoming months. I talked to the district grant manager this morning and she mentioned that it will be funded for at least one certification under the IT. So you can check that out, like CIS 27, CIS 25. And I don't know how RCC grouped them up, but so I'm meeting with Cal State San Bernardino on Wednesday. And we are going to talk about how that's going to be, but we started projecting vouchers for students for CompTIA certifications. So I know that RCC will be coordinating that, and also we on MBC side, I'm going to coordinate that with the director of apprenticeship. Just make sure that you register for the apprenticeship program. Okay.
Okay.
Yep. That's all you need is to register, and then when you're on track for it, you can get at least one free certification. I'm going to go for at least two, but we'll see how much money they're going to be able to expend. So far, they said that 3 won't be enough, but at least 2 is what I'm hoping for, like the Network Plus, the A Plus, or the A Plus and the Security Plus. All right. Hi, welcome back, everyone. I think just the 3 of you here, but I know that there might be people joining us. I'm a little bit under the weather, so I'm not on campus right now. And also, I'll see how I'll do tonight, and maybe if tomorrow we can do it virtually for my other class as well. Sorry. Let me go into screen share for the assignment in the notes. So this week we're going to talk about parallel processing to follow up with last week, in which we talk about concurrency. And this week it's going to elevate it, your programming approach, in that you are going to look at how memory utilization is used, what is considered a thread compared to a process, um, shared memory versus direct memory. And then we will take a look at some of the libraries and the framework that you can use. Keep in mind that parallel processing is common in a lot of the larger application and also data analysis type of application. So this is going to give you at least an introduction to TensorFlow and a couple other tools. So we'll talk about Openmp and TensorFlow at the end. Okay. So we will start with defining what parallel processing is, and basically it is a mode of operation in which tasks can be executed simultaneously. Now, last week we touched on how we would be able to release resources so that way things can be ran concurrently. In this week, we're going to touch on how we can set up thread versus processes. And in Python, there is a module called multiprocessing. And this module comes equipped with your Python built-in libraries, meaning that you don't have to install this additional module. You can use it as is, and you can incorporate the subclass, the class, and the members method from the superclass in this particular module. So the way that we look at parallel processing is it's going to help us reduce the overall processing time. So it's going to boost performance along with dividing the task into subunits. As you know, the OS, if you're taking a look at the operating system, it does this, right? When you're looking at Windows 10, for example, you would see that there are concurrent processes that's happening. And then sometimes you also see processes that are queued, which goes back to our concurrency programming last week, where it would be submitted and be ready to go. So now we want to be able to maximize the multi-core architecture in that we would use multi-processing to be able to allow processors, cores to execute our tasks at the same time. So that means that you are able to implement this for the more modern architecture. And in that, we would handle our data two different ways. The first way is to use common memory or shared memory, in which where we would have one location where all the subunits share that space. And you don't have to explicitly handle the communication if you're using shared memory. But in the case where if there's update or changes to the values at that memory location at the same time, you will have conflict. So the synchronization technique would be used to avoid those type of conflict. And we'll come back to synchronization near the end. Now, when you use shared memory, this is considered creating threads. And threads are simply independent subtasks that mainly share that one location in memory. And it would produce the context from that same space and be able to provide multiple execution from that same space. Okay, so if we visualize this, we would see that when you're using threads on the left, you would use the one location. Whereas if you implement processes, they are subdivided into separate memory locations. And so, and they are independent from one another. Okay. Now, later on, when you start creating your program, you would see that you can spawn and handle threads so that it cannot be used, but it cannot be used to increase the performance. So when we create the spawn, we would be able to use run, or we would use another method to create those threads. Okay. Now, Python is limited to its interpreter. in that only one instruction can be run each time, because this is the process is known as global interpreter lock, or GIL. So with that, what you would see is that each of the thread is going to require a lock, and the lock is released when it's ready to execute, or the execution is complete. So the threads are prevented from executing Python statements or some other threads when the other threads are being held in lock. So that means that when it completes, it's going to then be able to release. And then when it's before it executes, it needs to be put into lock so others can be executed. So we don't need to handle this explicitly compared to the processes, but the threads can be used for concurrency when you're handling things that would deal with IO for input and output, or when you use C extensions. So these are some of the benefits and the disadvantages that you would see from thread compared to processes in distributed memory. Okay. Now, the GIL can then be completed using the processes instead of the thread. So you would then, instead of using thread, you can then use distributed memory, and you would create processes that can be implemented for your application. So let's answer the first question. It asks you what parallel processing is, and you can summarize this. You don't have to put it for verbatim. It is a mode of operation where a task is executed simultaneously in multiple processors in the same computer. It's meant to reduce overall processing time. So we don't have to wait from one task to finish to go to the next. We would then be able to use the cores in our processor. So if your system like mine have 8 core, then you're able to maximize the core capability, compared to if we are using one task at a time and wait for that to finish. That's like using single core. That's what we talked about in concurrency last week. So we want to be able to execute multiple tasks at the same time. Therefore, we want to implement parallel processing or parallel programming. Now in Python, we would use Multiprocessing Module. That's the name of the module. And it is used to run independent parallel processes by using subprocesses instead of threads. So it's going to divide up the task into subprocesses, and we would be able to execute them at the same time. So if the computer has only one core, then one cannot use parallel processing. No. So you would then have to you would apply concurrency, in that you would only be able to execute. The processor is going to rely on its resource in order to execute. Now, if you consider, so in the case where if you want things to be simultaneous, things look simultaneous in that we would use concurrency. Now, if you want the processor to be able to handle some of the graphics type of applications, you can also utilize the GPU. And in the book, it mentioned briefly about that. I was going to expand a little bit on it, but I think I'm going to come back to that topic in the upcoming chapter. In that, when you're using the processors from the GPU, it's able to lift some of the tasks and be able to convert that for graphic-based applications like gaming, converting videos, and so on. So if you're using only a single processor, you have to find ways to maximize its resources in a single processor manner. When we're using multi-core processor, what we can do is we can implement multi-processes that's going to be able to execute at the same time by allowing each of the core to handle each of the process. And we're going to take a look at some of the program that you're going to be doing, and so you can see how it's timed based on how each core is going to handle your processes. Okay. Then, so we would handle our data. And so when you create threads, you would use shared memory. And when you create processes, then you would use distributed memory. So for question 2, it asks you, how is data communication handled in parallel processing? And that will be through shared memory for threads or distributed memory for processes. And keep in mind the distributed memory would section, right, the location into each sub-location into separate area space for each of the process. And it's going to implement what's called an interpreter for each of the process. Instead of where in the thread, it would use one interpreter, in that you read that it would require the GIL. So it would require certain tasks to be locked until it's done executed. Okay. Now, the difference between, and this is a little long, but you don't have to put everything in. I simply clip this from the notes. So we talked about shared memory already, and those are just subunits in the same memory space. So when it creates and when we utilize that space, what it's going to do is going to create contiguous area that's going to hold the threads. Okay. Now in the distributed memory, each of the process is stored in its own space, as the diagram shows on your notes. And with that, it would use its own interpreter. So what it does, it treats each of the process as its own, and it's going to use the core to execute the process. Now, starting with the new process, that will be slower than starting with the new thread when you look at the time measurement, and they would consume more memory in the overall long haul. Okay. Communication needs to be handled explicitly when you are working with multiple processes. So in this case, when you're using distributed memory, you have to handle communication, and that needs to be built into the development. Now the overhead is going to be more, so it's going to use more space. It's going to require more overhead compared to shared memory to be able to transmit that over the network interface. And ultimately, when we're taking a look at these applications, they are used for web-based. So what you would see is you would tie back to the IO, which is the input-output device, which is going to be your network interface adapter. Okay, so those are, in comparison, we would see that, you know, shared memory thread is simpler to start. We don't need to handle communication explicitly, but at the same time, right, it's not going to be the best approach if we were writing threads. So we would then capitalize on the actual processor architecture by using distributed memory with processes. Okay, and you would find this on our notes as well. You don't have to put everything, but in general, we want to highlight some of the main differences. So that way we would understand what is used and how it's implemented for parallel. Any questions? Let's see. And where can you find this verbatim, right? You can find this on the bottom of page 1 and page 2. Okay, so the top of page 2 and the bottom of page 1 of your notes. So as you can see here, we would have the diagram on the right shows that you would have processes, and they each would have their own sub location. their own location in the memory, and it has its own interpreter. Now, can you also implement asynchronous with parallel? Yes, you can definitely do that. So just like last week, when we define a function that's asynchronous, we would then just specify that it's async, right, using async IO, and be able to implement that in the program itself. So then when we call the function, we would do this more in the lab. Then we would see that we would just have to build a main and then use the main to call that function. So here I added a little bit on your graphic processing unit. So when you look at GPU, right, the modern GPU would have multiprocessors. It has its own RAM. So you would have the VDRAM. And then you also have implementation on how it's going to be able to execute and process the data at a certain frame per second. So compared to the CPU, between the CPU and the GPU is definitely slower than the CPU clock. Now, when your GPU compiled the programs, it uses two platforms. One is CUDA and the other is Opencl. And CUDA stands for Computer Unified Device Architecture. It is proprietary to NVIDIA technology. This is an API that is able to access other languages. And so the tool that is used to compile the program is called the NVCC, which is written in C. Inside this architecture, we would see that it has libraries that's implemented for mathematical routines, as when we convert code into 3D scenes, right? It needs to put it needs to compute the value and put that onto the grid or the matrix. So here you can find the documentation of CUDA Toolkit, which is the most current. Let me click on this so I can show you. And if you watch the video, it talks about some of the features, right? And so when you use this toolkit, you would use it with, for Windows system, you would use it with Visual Studio or an IDE that is able to have the C++ compiler. It is compatible with Linux and also Mac OS. So you can also look at their documentation. And it talks about how you can also implement this with the cloud. And then if you are interested, you can go into downloads. And so you would have options with the toolkit here. And then you also have specific library and SDK. That stands for Software Development Kit. Okay, so as you can see that it is able to work with different type of tools and different vehicles and so on. So if you are doing like robotic AI, that will be Isaac. Okay, Clara would be for AI powered for smart sensors. So if you're into IoTs, right, this is the area that you would look at. So there are different areas of this particular tool or overall toolkits that you can use. Okay. All right. Now, Opencl, unlike CUDA, this is going to be not proprietary. It's open technology. And so when you have other vendors who are not NVIDIA, they would use Opencl. And this is used to write parallel programs that can be compiled for CPUs and GPUs. And if you wanted to take a look closer at the information for Opencl, you can click this link. Okay, and here it talks about, sorry, the versions, so what's included with the 3.0, right? What does it support? The type of company that uses Opencl. Okay, even NVIDIA contributed to the project. And this is for low-level parallel programming. So it gives you a little bit of the overview on that. And you can implement runtime API or platform layer API. So this is mainly going to handle the GPU, right, compilation. Okay. Now, when you're looking at writing these programs and how it's used, you have to think about the type of algorithm that you want to take advantage, especially when you're working with GPU. And how the operations will be performed per unit of time. So the throughput is very important. CPUs are faster at producing the result, which is known as latency, compared to GPUs. So we can't expect something that would be compiled at a GPU level to be equivalent to the CPU, as the clock for CPU is higher. Clock cycle is going to be faster. Okay. And when you look at example that uses parallel processing, you would see there are quite a few examples that relates to graphics. Okay, so in the next part, it asks you for number 4, compare to CPU. How is GPU produce data for graphics application? We would say that GPUs have thousands more processing units, which produce data at approximately 60 frames per second. Simply overall, it is slower than CPU clock speed, even though it has more units. And you can find this information in the notes as well. I only clipped one section for that, for the answer. Any question? Okay. So here you would find a comparison for those, and then where I got the answer for that would be right here on page 2. So let's talk about multiprocessing module. This is used for parallel programming in Python. Using this module, we can spawn processes and not have to deal with GIL. It is easy to use, and we're able to submit tasks and synchronize tasks. The link provides you the documentation. Now, I know that the book and even my notes only going to cover a section of this, so it will be best if you work with this particular module, you need to dive a little deeper, take a look at their documentation, right? I think the text doesn't really talk about pipes and queues in this chapter, so there are some examples. It jumps back and forth on some of the areas with this. And I also use additional external resources to support and give you examples, so you can at least write a simple program with multiprocesses. Okay, so this is the documentation, and it talks about multiprocessing is the package for spawning processes using API, very similar to threading. Okay. Now, when you take a look at the example below here, you simply have an import statement at the top. And in this case, following the example, we would see that it uses pool from multiprocessing. And what we're doing is we are going to create a pool, which is an object, okay, that's going to give us the function for the multiple input for the values. So because we're using a list 1, 2, 3, it's going to use that object to be able to implement multiple input. So that would make it distribute the input data across the processes instead of just for one, but for multiple. So the example here, what we're doing is we're going to take x and we're going to square it. Right? X times x is x squared. So we simply define a function, which is called f. Its parameter is x. And we want to return x times x. Now we have to implement a main in which it's going to call that function. But here what you can see is it says with pool 5 as p, it's going to map, right, the function for every single input, 1, 2, and 3. So if I take 1 times 1, it's going to give me 1. That's what's going to output here. 2 times 2 is going to give me 4, and 3 times 3 is going to give me 9. So it's able to map, right, this object for every single input across the process. Now, that's one example. What about another example in which we need to use some of the method, right, from the process class? And this is from the module. Okay. So in multiprocessing, processes are spawned by creating a process object. Okay, so you have to have an object, which is here. And you would use a method called start. So that it's going to be able to create the process. Okay. So in this example, what we would see is that we import multiprocessing and from the module, we're going to import process. We define another function. It's going to take name and it's going to print hello name. Then in the main, we declare an object called P. And that object is going to be a process object. Its target is going to be function F. And the argument, what it's going to plug in is going to be the name Bob. So it's going to say hello, Bob. In the following line, right, we're going to create the process. And for this, it's going to join the child process and finish. And you're going to see the order when we do the exercise. Okay. So those two are some examples that you can take a look at to start because they are fairly simple. Okay, for question 5, going back to the GPU, what platforms can be used to compile programs for GPU? We would use CUDA, Computer Unified Device Architecture, which is proprietary to NVIDIA. and Opencl, which is open technology with the ability to write parallel programs. And that would be for all the other vendors for CPU and GPUs. Any question? So in number 6, it tells you to look at multiprocessing documentation or your notes. And you need to look at the given program which implements multiprocessing module. And you need to explain how start and join are used. So the structure of this program is similar to the example we just looked at. We have the import statement. This one, it actually import OS because we want to be able to get the processing ID. Then we have that's the first function is the info. And in this function, we just have display or print information. It prints the module name, the parent process, and the process ID. So that's why we use OS, because we want to use the get PID from the OS module. In the second function, function F, is that we are going to call the info function. And we are going to print hello and the name. Then we have the if main statement. So in main, we're going to call info. We are going to declare an object called P, and that is a process object with the target F for our function F, and the args is Bob. So unlike the previous example, in this one, we have multiple functions, and we use the F to call info and the main to call info. So we wanted to print out, right, your process ID information when it's executing the function F. And at the end, like the other example, we would have the start and the join method. So as you read further in the notes, you would know that the start is used to spawn processes by creating a process object. So start method is used to spawn, right, by creating process object. And I note here that this must be called at most once per process object. So it's going to have to be called at least once. It rearranges the object's run method to be invoked in a separate process. So it is different than run in that it invoked in a separate process. Now, the second area is where we will look at the join method. And the join method blocks the execution of the main process until the process whose join method is called terminates. So without the join method, the main process won't wait until the process gets terminated. So if you comment out the join, you would see the output to be different, and we're going to test that. Okay. So as you're using these two methods at the beginning to write your parallel processes script, you want to know what they do. Any question? Okay. So this is the program. Okay. This is the program that's used for that question. So when we run this, okay, here at the first, it gives me main line. So because that would be main, so this is where we call the info. And so it's going to come back over here and it's going to print these, which is what we see. Okay. And then it's going to give me also again the second process, which is going to be hello Bob, as we have the F target here. Okay, so as we call info first, info is going to give us this. And then when it starts the function F, then it's going to give this process ID. Now, if we comment this out, right, you notice that it does not use the target. Okay, it's only going to give me the first function call, the first process, which is the parent. Now, also something to point out too is when you look at the prior, when I left the join not commented, this process ID becomes the parent process ID for the second. So when it gets to here, okay, and when it joins, the previous process becomes the parent and the second process becomes the child. Now, when we take out the comment and when we comment it, we run, it only execute the info. Okay. And it left out the child process. So it doesn't join the child. So that shows you how it's able to wait for the call to be terminates, and then without the join, the main won't wait. So you want the main to wait for the child process to join, to be executed. Okay. Any question on this? Okay. So now what we're going to do is we're going to look at the pool in class. So there are two main objects in multiprocessing that we can implement for parallel execution. That will be pool class and process class. In the pool class, you would see these methods: map, star map, and apply. And there are others. So earlier we looked at the example for this is where we take X and we square it, and we're able to use the pool and map method to be able to distribute, right, the process for multiple inputs. Now, in the next example, we can see that we can spawn by using process object instead of pool. And we use start, just like what we talked about earlier. We would use the start method to spawn. Okay. And you always want to follow that up with join. Otherwise, it does not execute the target function. And that's the example that I clipped earlier. So here, I broke it down and I give you the more details. So if you want to expand on what we wrote down for the previous question, you can also add. So the start method start the process's activity. This must be called at once per process object. It rearranges the object's run method to be invoked in a separate process. For join, you do have an option to put in the timeout. Okay, as the parameter. So the argument timeout, if you don't put anything there, it just default to none. So you can put a value there that will be the seconds that you want it to wait, to timeout. Okay. So what it will do is that it will return none if the process terminates or if the method times out at a certain seconds. And you can join it as many times, but it cannot join itself because there's a deadlock. So the join method really blocked the execution of the main process until the process whose join method is terminated. And it will not wait until the process gets terminated if we don't join. So let's take a look at this example. In this example, we're using multiprocessing and we're going to import process because we are going to use the object, the process object. And we're going to import time. So we have a function called fun, and we are going to print start fun. So that way you know when it starts. Like last week, we are going to pause it for 2 seconds. So we're going to do a time.sleep and then put in 2. And then we are going to print finish fun. And in the main, we simply create a process or an object called P, and it is a process object. And we simply use fun as a target function. Then we would start and join for that object. And then in the main, we simply just print again, starting main, call main, and then print for finish. So the output you would see is that it's going to do start main, starting fun, and finish main. So the finish main message is printed after the child process is finished. Okay, so you would see the order there. But if we comment out the join, it's only going to have main as it would print starting main and finishing main. Okay, it will not have the target function to execute. Okay, so before we look at the next example, let's go and do a short little program for our assignment. So for number 7, it asks you to look at the documentation and notes, write the program that implements multiprocessing module to define a function that prints hi, your full name, using process start and process join method. Provide screen capture and script and output. So in this one, we're just going to have a function that print your name. And then we're going to use the main, okay, to start and join. Okay, the target function. So it will look something like this. Let me clear this. So first line, you would have the import statement. So we would say from multiprocessing import process, because we are using the process object. Then we can just have a function. And in this one, I just simply copy the example. So we can say function F, or you can say function full name. And then we want to pass name there. And then we would print hi and the name. Then for main, we would say if, and this is the double underscore name, if namespace of our name is, right, main. Then we declare our object in main as P. P is a process object. Its target is going to be the function. Whatever you name your function from here, you would bring it down here. And the arguments that you're going to use that's going to plug into name is going to be your full name. Then we're going to start. So that means we're going to spawn. Okay, and execute. So when you run this, oh, what happens? I have something here. It wanted 2 arguments. Yeah. So we would leave that, make sure there's a comma. I took out the comma and it didn't like it because it tells me that for the target, it needs to have 2. Okay. So here we would be able to see, and if you want to print on the next one, we would see the order when we use the main to call it. So any question? So the takeaway from this is that when you use multiprocessing, you have 2 areas, 2 type of objects that you can use, the pool and the process. And for spawning, right, process, you need to import process. Then you are going to define your function, what you want to execute. And then in the main, you declare your object and then use that object to with the start and the join method to spawn and to execute. And don't forget that you have to implement the target, which is your function. Any question on 7? Now the book uses various examples. They keep the same example that they used in the prior chapter, like the square, some of the calculations, and then the particle simulator. So you can see the difference in how they would implement different approaches in each chapter. Okay. It should be. So you can try, yeah, you can try it with, I'm just simply using, let me double check to see if I did add this in ultimately, but I don't think I did. Yeah, it should be out of the box. You don't have to install multiprocessing. If you have Visual Studio, you can try it with VS. Okay. Question.
Professor, mine keeps giving errors too when I do it on Tawny.
Do you have this?
Let me check.
Make sure you have the comma. Make sure that you have. If it's getting errors because it's syntax. And if you want to, so the program that I use is this one. Okay. And it's under the process class. So let me put it into the chat. If you go to that link, and then if you go down to the section where it's process class, you would see the example that I use is this one. And so you can check your syntax.
Okay.
Okay. I use Tawny and I don't know why. Yeah, Visual Studio should build it. Yeah, I'm running it in Tawny right now, as you can see here. Okay, good. So if you use it in Ubuntu, if you have a Mac OS, you should be able to also run it there as well, right? So now we know multiple ways to test it in the case that if one IDE doesn't work, you can always use the other one. But yeah, I did not install multiprocessing on this. I just run it straight. And I simply took, right, the example that's given here in the documentation, and I modify it and I use it for this, for 7.
Professor, I tried copying and pasting the one on the website for what was under process, and it still gave me errors.
On Tawny?
Yeah.
What kind of error does it give you?
Let me read out loud. So it's
you can hold on. Let me change the security on there. Okay. Yeah, so Michelle said check the quotation mark. So if you copy and paste a symbol in, sometimes it doesn't interpret the symbol.
Okay, let me actually retype my quotation marks. And
yeah, some of the symbol, like sometimes comma, semicolon, quotation mark especially, those don't interpret well going from one application to another.
yeah, seems like maybe problems with commas, and let me try It does not want to take it. It says something about file string line 1. And yeah, let me actually share my screen.
Okay.
Not sure if I did something wrong on syntax.
I think something's funky with the main. Let's see, retype the symbol for the namespace for main. If name, make sure you check the underscore.
Okay.
It says can't get attribute F. F name. Hello name. To the module built-in self-reduction. Yeah, check target F. Target equal F. Yeah, everything looks the same. Let's see. Target equal F, comma, args. Let me double check yours. Comma, args equal. Yes, it's still giving you errors. There is a, okay, yeah, double. Yeah, run it again. Yeah, it's not able to see F. Module main built-in reduction. So me and join. Yeah, I have to find out why it's giving you that and not on mine. I'm using the same exact one. So let's see. Yeah, I think it has to do with that line or the if statement there. Because it says self for the reduction bigger load from parent. It's not able to find that target when F. Okay, the attribute F. Yeah, so and you check all the quotation mark for main and Bob.
Main in Bob, yeah, I changed it. I changed the quotation and the comma after I pasted it.
For all of them, right? For
Yeah.
line 6, line 7, and line 4.
Yeah.
Okay. Yeah, I don't understand why it's doing that, but it should. Let me find out what that is. I think it's not able to start, so it's not able to spawn. That's what it's telling you in the set there, and then it's not able to join. Multi-set processing input process. Yeah, same exact. Attribute error cannot find attribute F. Hold on 1 second. Let me check something. Yeah, otherwise it would just be syntax. How about if you add in, you define another function and then, okay. So let's come back to that. I'll show you another way that you can actually use another function. So maybe you can change it and add in another function, okay?
Okay. All right.
Yeah, I think it might just be something with the symbol or something that is very small.
I'll try retyping it and running it one more time and see
Okay.
if it works.
Yeah, maybe open another file and then retype it and see what it does. It should take it. Yeah, Ghislaine said that his Tawny doesn't work either, so he ended up running it on Linux. And
Okay.
yeah, so if you want to test that, you can, but it should work in Tawny, I think. I don't know why. I have to see. Hold on, let me take a screenshot of your. Okay, now you can unshare.
Okay.
Let me paste that real quick. I wanted to see. Okay, so another way that we can, instead of just using, right, main like what we previously done, which is like this, where we would use start and join in main, you can actually use it in another function. Okay, so here is the next one. I wanted to show you this. So I would have the same thing. I have from multiprocessing import process. In this one, I wanted to put in the time because I'm going to pause it for 2 seconds. So I would import time. And then I define a function called show name. I print my first name. I have it sleep for 2 seconds. Then I print my last name. Then I add a second function. I declare another function. And in this function, I call it main. And I have an object P, which is a process object. And the target is just going to be my first function, show name. Then I would have a start and a join for that process. And then below that, I would say if, right, name is main, it would print starting main, call the function main, and then print finish. So let me clear this. When you run, you would see that you saw that it print the first name, then it pause, it wait 2 seconds, then it prints the last name, and then it's going to come back here and it's going to print finish main. Okay, so it starts here. And then since we call main, it's going to go up here, which requires it to execute this function. And then come back here. And that's when it exits. Okay. So you can simply do it this way. Let's say if I comment this out, okay, and I just simply use like this, right? It's still going to fulfill the purpose of the other one, right? It's just going to be that it's going to start here, go up here, print my first and last name, print this, and then come back here. So we don't have to include this. We can just simply call main inside here. But I wanted to show you like how the sequence of it, it's going to start there. And then when it starts spawning the process, then because we called that function here, it's going to start the spawn. And then it's going to go to the target, which is this function. It's going to print. So you can do it this way as well. But in number 8, it asks you to have a pause. So we can implement the time wait for 2 seconds there.
Professor, this one doesn't work either on mine.
Okay. So let's try this. Go CMD.
Yeah.
Let me see if it helps with. Yeah, I don't think it's gonna help because it's gonna tell you that it's already been implemented. You can't pull it without using a or on Tani, see if you can just manage. Let me see. Is there a package? Hold on. Yeah, so go tools and then manage package. There are 2, right? There's this and then plugins. So if you go manage package and then just search for multiprocessing. See if you install it, if it's gonna be able to, because this is written for 2425. So that's why we don't really need to. Yeah, see if you can install it and see if that works.
Okay.
Okay.
I just not want to install it either.
Yeah, it's gonna give you like the same thing because I couldn't pivot. But that's interesting. Let me see. Let me look at your error real quick.
Okay.
I have it. I screenshot it earlier. Yeah, it has something to do with your main there. Spawn main. Okay. And you said you typed that in?
Yes.
Okay. Yeah, if there's a join, oh, okay, I see there's a, okay, let's see. It's not a runtime error. Yeah, if it's from the documentation, I don't know why it doesn't. Let me see. Start and join P. Try doing this. Try this. Let's see if you can do p.run. Let me see if it does. Yeah, so it would not run the target after that anyway. Yeah, I don't see why. Well, I think that maybe because I have some packages in here that allows it to work, but I didn't really install anything to start. This is exactly like how it would be in the documentation. So let me find out why yours is doing that on Tani. If it's missing something, we can probably try to resolve it. Okay.
Yeah.
Yeah, but yeah, it should be running. If not, if you have Visual Studio, you can use it directly in Visual Studio and it should still work too. That will be another suggestion unless you want to use Linux and it should run.
Okay. I'll go ahead
Okay.
and do that.
Okay. All right. So let's pick up. So we looked at numbers 8. Okay. So it asks you to add the C2, and then we want to have the function. So we would print the first name, wait 2 seconds, print the last name, and then we would have a second function in that you can just make it main or you can call it whatever you want. And then down here, if main statement, then we just call that second function. Okay. And you don't have to add these prints. These prints are really to help me see, right, the sequence for that. So it starts here, it's gonna go up to here, and which is gonna give me the target. It's gonna print that, pause 2 seconds, and then print this, and then come back here. So in the example, this is the example that I use. Okay. So you can simply have a first function, a second function. And that allows us to use the second function to target the first function. And then for the main, we just call the second function. Now, you can also look at the join order by implementing different objects, right? Each object for each process, P1, P2, and P3. And in this, you are also going to use argument like how we use name, Bob, or your own name. Okay. So,
Professor, are you sharing your screen? Because I'm not seeing the screen.
oh, sorry, I didn't click the blue button. That would be helpful.
Thank you. Thank you.
Okay, yeah. So for the order, where we can take a look at the join, okay. So in this example below, after it talks about start and join, okay, so this is the example program that I use for number 8. Now, for the join order, we have a function. In that function, we simply print. We're also going to have a sleep. Okay, so we're going to pause and we're going to print again. Now in the main, we are going to declare object 1, which is P1 for the first process, object 2, P2 for the second process, and object 3, P3 for the third process. And we can still reuse this function to execute for every single process. So here, our target is going to be that function. But notice that the argument, you can update the argument. As they are individual process, they will not impact one another. Okay, compared to thread, where if you update that, it will change and that will cause conflict. So here, after we have each of the process, we want to start them and we want to join them. Okay. So that means that after we start, at the end, we're going to join them all together. These are comments out. So you don't want to join right after the start for each one. You want to join at the end. So in the main, we simply call the main. Okay, so let me run this. Okay, so that's the join order. Okay, as you see, we have start for each one. And then we would have the join for all 3. And then we call on the main here, which has all the 3 process declaration. And so when we run this, okay, so what happens is it's going to start with 3S. Okay, so it's going to start from the last because it's going to be last in, first out. Then it's going to go to the 2 and then the 1. And so when it finished with the join, it's going to do 1, 2, and 3. And it's going to finish main. It's going to print that here. Now, if we comment this out and we uncomment these, let's say that we put the join for each of those there. Okay. So you would have, right? So it would start at the top. Then it's going to finish. Then it's going to start 2. It's going to finish 2. And it's going to start 1, and it's going to finish 1. Okay, and then it's going to finish main. So unlike the other one, as you can see, if we want them all to start together, then we would need to join them at the end. But if we want them to start and finish sequentially, that would defeat the purpose of having parallel, right? Then we would then do start and join, and then start and join, and start and join. Okay, so if we comment these out, like what we've done earlier, and we want to join them at the end, it would queue all three processes and execute all three processes together. Okay. Okay. So that would be the join order. So you can play with that one. And I copy and paste this in so that way you have the code, or, so you don't have to retype it. Now, the next one is using a live method. So is alive just allows you to verify if the process is running. Okay, so you can simply have that print, and you would use the object, and then the method is alive. If it is running, it's going to give you true. If it's not running, it's going to give you false. So the process object is alive at the moment when you use the start right here. And it would then return until it finished, which is when the child was terminated. Now, when we wait for the process to finish with the join, the process is already dead. So when it gets to here, it's already out. It's already completed. So if you comment at the join, then it's going to keep that process alive. But if you add in the join, right, it's going to leave that process and it's going to get to the next process. So that's going to make it false. So I'm going to run that so you can see. So here's the alive. Okay. We have the is alive method there. We comment at the join. And then we're going to run this. Okay. So here it prints main fun. And it tells me that the process is alive. That's true. Now, if we add in the join and we run this, right, it's going to give me some warning, and it's going to tell me that the process is not alive. False. It's not running. Because then it has to wait for this. So that means it already terminates. So it becomes false there. Okay. So now what we have is we have some example that you can look at and look at how you can determine if certain processes are running. In the next example, similar to the documentation, you can use get PID, which is a way for you to look at your process ID. You can implement that into a function, use another function to be able to print out each of the process ID. We've seen this earlier from the documentation. And then you would use the start and the join to be able to see the parent and the process ID. Okay. And here's that example. So we would print, right, the parent ID, the process ID, and in the main, we would then get the child process ID. Now in this one, we declare two objects. the first object is for the first process. We would do a start and a join there. The second one is for the second object, which is the child. Okay. So when you read this, you would see that we would have the function, the process ID. And when it calls, the parent ID is the same. Okay. But when you look at the child ID, that will be different. Okay. So that comes from this right here. So as you can see, this is a way that we can also identify which process has been executed. And there's inheritance from the parent to the child ID or the processes, even though we're targeting the same function. Okay. And again, we can obtain that by using the OS package. Okay, so let's talk about pool object now, since we saw a little bit of it earlier with multiple input. So pool is used to spawn a set of processes. Instead of one, you can use pool for many processes or multiple processes. And these are called workers. It allows us to submit tasks and be able to map to those tasks synchronously or asynchronously. So using pool, we can use the map method, which is a function that each of the element on the list would be applied to the process. Now, when you declare the object, you simply just give it a name, and then you would use the pool class. Okay. The way the book uses it is that you can specify the number of processes and then use the list to apply the input. This is also similar to the documentation. So this is a way that we can control multiple processes for the job that's submitted at that point. And the map allows us to iterate through groups or sets of tasks. And it is a parallel equivalent to a way that we would do a built-in map, which blocks the main execution until all of the computational is finished for all the processes. Okay, so that's why you would see at the end, it would print like, you know, main finish when you look at some of the program. So now when you take a look at this example, here we are just using time to measure at the top. We are going to import pool and we're going to do a CPU count. So it's going to go to your processor and it's going to count how many cores you have. And we use a similar example to the textbook where we want to return the square of n, right? But with it, we would implement the sleep for 2 seconds. We have a second function called main, and we use that to start the timer so we can measure the time that it executes. Then in the next line, we would print, right, the CPU cores, how many processor you have. So if you have a quad core, it would say 4. If you have an 8 core, it would say 8. If you have a 12 core, it would say 12. And we want to square the value 2, 4, 6, and 8. And like the documentation, we would use the with pool statement. So with pool as pool, our result is going to be map of, right? Here is where we call the square function, and we would use values, which is the tuple, okay? And we would print out the result. Then we're going to finish the timer, and we're going to print the elapsed time, taking the end minus the start. So we would see the number of seconds that it uses to execute those. And then in the main section here, we would call main. So when we put this program and run it, okay. Oh, this one, sorry. So we originally have 2468. And when we run this, it tells me that I have 8 cores, right? And it's going to square 2, 4, 6, 8. It gives me 4, 16, 36, 64. The elapsed time is 2 seconds, 2.27 seconds. Let's say that if we add in more value, 10, 12, 14, 16, 18, and 20. Okay. And we run this again. So using the same processor, right? When we add in more than twice as much of the number of elements that's in that tuple, we see that it's about double the time. So what this does is it's going to map each of the value for that task, which is a square. And what I would do is I would be able to treat each of the process individually for each of the value. So when you have a container that have a number of elements like this, like the tuple that we're using, what you would do is you would have to create a pool, and you would use the map method to be able to distribute the value for the process, even though we're using the same function there. Okay, so it's going to be able to map this for the function, and this for the function, and this for the function, and so on. So as you have more input, you would see the increase in your time. So I added in 10, 12, 14, 16, 18, and 20. We had double the time approximately, right? 2 more minutes in comparison. That's able to execute the square for those values in addition. Okay. Any question? So in number 10, it asks you to describe the functionality of pool and pool map in parallel programming. We can say that pool controls the pool of worker processes to which jobs can be submitted. It can take a number of processes as parameter. It is a value with which we can experiment. Actually, we can delete that. I pulled that from the notes. If we do not provide any value, then the number returned by the OS CPU count is used. The pool maps method divides the given iterable into several chunks, which it submit the process pool as separate tasks. So what that would do is it's going to treat that as a number of different tasks as it would distribute the value for each of the process and it execute the function. The pools map is parallel equivalent to the built-in map method. Map blocks the main execution until all computation is finished. You can find this in verbatim on the notes, but you can summarize it. You don't have to put it word for word. So the structure of it is that we would use the pool object, and there are several methods that we can use. We can use map, star map, right, as it mentioned at the beginning. So we'll take a look at those. Remove this. Okay. So when I ran this earlier, I have this many, right, in the container, and I have 2.26 seconds. And then when I added more values, I would see that the time is increased. So we would use map with pool, and we would use star map when we need to pass multiple arguments. And the elements of the iterable are expected to be iterables, right, that are unpacked as arguments. So in this example here, we would pass two values to the power function. Okay, here, x and n. So when you use map, it's only able to take one argument. When you use star map, it's going to allow you to pass multiple arguments. So we have a function called power. We would use x and n. We have a 1 second wait for sleep, and we would take x, right, raise it to the n. Now here, different than the last one, we would see your values, right? Now we now have two values, the base and the power, the base and the power, the base and the power. Then in the result, we would have pool.starMap, and we would specify, right, that's going to be power, and the second argument, that will be values. So when we look at the star map example, when we run this, okay, it tells me that to compute using 8 core for 2, 4, 5 as base, and 2 to the second power, 4 to the third power, and 5 to the fifth power, it took 1.28 seconds. And you can increase this, right, to see how long it would take for more input. But as you can see, that when you're using multiple arguments, you need to make sure that you use star map with pool object. Okay. Any question with that? And so you can test this out using this program so you can see. So what if you have multiple functions, one for each? So in this case, we would use, again, multiprocessing, and we would import pool. We also use func tools. So here I have X, right? For increase, decrease X. add X and Y, and then for SMAP. So here I add 1 to X, I subtract 1 from X for the decrease function, and then I add X and Y for the third function. And then I have return F. So as we import functools, we would then use functools here. And this is what they call a partial. So you would use a partial method, and then you would be able to use each of the function and then the value for the parameter. Okay. So function and then the value for the parameter. So you would still have to use map, but in this case, you have to, in the result here, when you do the map method, you have to pass all of the functions. Okay. And we redeclare what those are here. So you would use finc, f decrease, and then f add for these 3 objects. So use those, and so it's going to treat it like a list here. So it's slightly different than the last one in that you're using functions. On this one, you have multiple functions, and then you would declare the object and what that object is using partial, and you would pass those objects into a list. And that's part of the map method argument. So this is, hold on. I don't think I put, yeah. I didn't put that into here. I have some stuff for the worker, but you can run that. I think I had a result. This one, we didn't really have anything printed, so you probably won't be able to see it, but you can also add the print statement, and so you can check it. It's only going to print the result. Okay. Now this stuff, some of the example that I added here that came from an external source. It's not the book. The book talked about map and pool, and it provides some example. But I wanted to show you that you can also use multiple functions, and then you can use star map for multiple arguments. After this, it goes into executor interface. And this is for asynchronous execution. It uses what's called the thread pool executor. The documentation, they provide this example in that you would be able to set up how each of the function would display the result, and then you can have it pause for 5 seconds. So here I have wait on B. It's going to wait 5 seconds. It's going to show B results. And then wait on A. It's going to wait 5 seconds. And then it's going to show A results. Okay. Now, when you use executor, you would declare an object, and you are going to use thread pool executor. Then you can specify the maximum number of workers you have. That means how many processes that you are going to be running. So if I have 4 processes, 4 functions, I would put 4 here. Since this program only have 2, then you would specify 2 here. I have the first object, which is A, and it is an executor interface. And you are going to use a submit method And in that, you would use the function name as the argument here, wait on B. So A is going to wait on B and B is going to wait on A. Okay. Now in this section and also in the book, it talks about wait on future. And last week we talked about future. It keeps track, right, of what has been submitted, the status of that, and also what potential value in that particular process, right? So here in this function, wait on future, we have an object called F. And again, we are going to use executor submit. And here is where we would operate the calculation for the power. We're going to take 5 and we're going to raise it to the second power. And if you read the comment, they put that this will never complete because there's only one worker thread and it is executing this function to give you the result. So it will never be able to give you the result for the exponent there. Okay. Then in this, we would have the thread pool executor, and that's going to be one worker. And then we are going to use wait on future when we submit that. Let me see if I have that. Hold on. Maybe I didn't put it. Okay. So in order to extract the result, it's going to use what's called two functions. It's going to use concurrent futures wait. And we talked about awaitables last week. And it's also going to use the as completed functions. Okay. So the wait functions accepts the list of the future. It will block the execution of the programs until all the futures have completed their execution. And we talked about the space as in the future that it's going to be able to keep tab of the process status. Now, for the result, if we're using the result, we can use future as completed, or we can use future result method. Okay. If you want to take a look at the example closer, you can go to the documentation. In the concurrent future section, it talks about how executor interface is used. So the takeaway from this is that I want to show you that the number of process that you're going to use is going to be the maximum worker value that you are going to include in the parameter. Okay. Now when you declare the future object, you always want to use the submit method as part of the executor interface. And if you want to get the result, you can use future.result, or you can use the other two methods. This is the method that's going to able to obtain, right, the result for your future at that location. So in the assignment for 11, it asks you when using the executor interface, what is used to extract the results of the future instances? that will be futures wait and futures as completed functions, or you can use future dot result. Let me fix that. We're almost done. Any question with this? Okay. So for the next part, it talks about synchronization and lock. When you're working with multiprocesses, you can define variables or arrays as shared memory. Okay. And you would use value method to be able to pass the data as string, integer, double, float, or whatever data type. You can also update the content of the variable through the value attribute. So what you would use is you would use the value attribute to be able to work with variables and array in the shared memory. So this example, it shows you how you can define a function and you would use the value attribute here. So here we would say that the value, this is a pi value, right? 3.1415927. And then we would use a for range to be able to access the value of the value in the array. So what it would do is it's going to be able to give you, it's going to plug in 0, -1, -2, -3, -4, and so on to be able to look at the value of D, which is this, and then the I is going to be part of the array. 0, -1, -2, -3, -4, up to 9. So that's going to give us 10 here. So when we print, we would use the value attribute for the number, and then in the array, you simply just use the colon in the square brace to be able to print the entire length of your array. And if you want to take a look closer, it gives you the explanation for that. And this is what's called a shared C type. So when you refer to that documentation, if you go to this section, it talks about how multiprocessing would allow you to have the same shared location, right, for your array and your variable declaration. And you would be able to access the value by using value attribute. Now I included this. I think the book has a different example, but this shows you how you can use the manager method. And this is often used for server in that it would look at, things that are in queue, certain apply conditions, values, sometimes dictionary based type of container. So this is a way that we can access shared memory objects and using the manager method. So a single manager can be shared by processes, and it can be shared by number of computers over the network. So that means that it would use one location that could be shared by many different systems, and that could be shared by many different processes. And that's how we would be able to implement this. Okay, so you can use the process object with the manager method in order to define what you want to do for that server there. So it would store D1, D2, right, D.005. So these lists, it can be stored and it would be able to access by a number of systems and a number of processes. Okay, lastly. And also I wanted to point out, you can use terminate method to stop a process that can cause any shared resources to become broken or malfunctioning. But you can use the global lock to prevent multiple processes from executing. So that's the two different things, is that lock prevents the processes from execution, and terminate, stop the processes that would cause problem, right, for other processes. So you can terminate or you can lock. Lock is just, we can stop multiple processes from execution, and terminate prevents the shared resources processes to create other issues for others. Okay. All right. So as we come to the end, there are a few questions. So for number 12, describe the use of lock in parallel programming. That will be, lock prevents multiple processes from executing the protected section of the code at the same time. And the textbook talks about 2 additional tools that you can use in parallel processing. One is Openmp, and then the other is TensorFlow. And TensorFlow is well known in machine learning. Okay. So for Openmp, I think the textbook gives you some example, and I also include links to some example there. So Openmp is an application programming interface, so your API that supports multiple platforms for shared memory multiprocessing for C, C++, and other platforms. So it will work with Linux, Mac OS, and Windows. It has compiler directives, library, subroutines, and environment variables that will influence runtime behavior. So you can take a look at Openmp. If you go on their website, you can find that they have example, and then they also have book resources, okay, and tutorial. Okay. And then when you look at the example, it's in like a book format. So it's a PDF where you can go to certain page to take a look at, you know, their like parallel constructs, how to map, and so on. So they have a lengthy example in that it would be broken into different subjects. Now, TensorFlow, this is used in machine learning. It offers multiple level of abstraction, so you can choose whatever you need to train the model using API. And the API that we can use is Keras to start. So TensorFlow when you take a class like machine learning, you would use TensorFlow along with other tools. It is an open source platform machine learning. It is flexible. Now, if you want to make a large machine learning training task, you would use the Distributed Strategies API, which is different than the Keras API. That would be the initial high-level API for training models. So you can include this in your answer. And how do you install TensorFlow? So when you visit their website, you would see that you can use something similar to your Jupyter Notebook, okay, through Google. But you can definitely install TensorFlow by using pip install. And you can do the user, this is for specific user, but you can do pip3 install upgrade TensorFlow. In Windows, it's recommended that you use Visual Studio or an IDE that has compiler. So here's TensorFlow. For Mac OS, you basically also use the same thing using pip. If you don't have pip installed, you can also use wheel. So there you go. Now, let me see if I can go back. If you look at their tutorial for beginners, if you go to the quick start, right, you can run directly in Google Collab, which looks very similar to your Jupyter Notebook. This is what UCR uses when they teach this type of course. So here it shows you how you can work with Keras, and TensorFlow is to build the neural network for, to train a certain neural network using Keras. Okay, so it walks you through every single step. You can run each of the statements, and then you can build your model, and then you can make prediction, and you can train your model. And this is what you would see in data science and analytics. So I encourage you to check that out. Any question? I could not get question 9 on Ubuntu. Okay. So let's come back to that. Okay, so for 9, it says, refer to Unit 8 notes, write a Python program to implement multiprocessing module and defines a function that can be used for 4 child processes. The program should display the process ID. The parent for child process provides screen capture. So I think we were looking at different processes earlier, right? So you would use this one. Let me go to the notes section and I highlight that for you. So that would be on page 6 and use this example. The only difference is that you have to add 2 additional processes. And so you can just simply have P3, right, process, and then your target, and then the function, start, and then join P4, and so on. So you can use this example, you just have to add 2 additional processes. So it would look like this. And then P3 is going to be join. And then you just need to do a P4 and so on, right? And then when you come down here, yeah, so you build everything into main and then you call on main, and that should be all right. Yep. So make sure that we call the main function in the main. So this is number 9. Okay. And again, for those of you who didn't catch that, 9, look at page 6 to 7, the example on the OS process ID. And then you just extend it by using 2 additional processes and run it. Okay. All right. Any other questions? Okay, so Sinelli and